Okay, so the last video, just give a very quick review, hopefully for most of you into OLS multiple regression. We want to look a little bit more intuition, so we'll take a look at the graphical example. So let's say we have a data set, very simple data set. There's one X variable and one Y variable. And for our XY combination, we have 5 observations, okay, Y1 through Y5. So for Y1, we have an X about 1.1, and our Y is about 2.75. So this would be our data point Y1. Okay, we have our linear model here, which is a function of where our outcome of interest y is a function of our parameter beta 0, which is the intercept, our beta 1, which is like the slope of our line, and then an xi, which are our observed data points for x, and then this unobserved error term. Okay, so what we want to do is we want to draw a line the best we can so that our line comes as close to representing our observed data points as possible. We have 5. And you can imagine this as a repetitive kind of process. We could draw 100 different lines at different angles with different slopes, different intercepts, and we can observe which line is going to be the best fit to our data point by carrying out our OLS regression. So the idea here is that this line that we've just drawn, the blue line, is modeled after this equation. So our yi hat is going to be the points on the line that match our data points, okay? So we have a beta 0 plus beta 1 x is going to give us our observed data point, or not observed, our predicted data point, which is a prediction for our actual observed data point y1. So for every data point, we're going to have a prediction. So here we see we have 5 data points and we have 5 predictions. Given a value of x, what we predict the actual y value will be. Okay, so what we want to do in OLS is we want to get the distance between our predicted y and our observed y. And this distance in the red line here is what the error is going to be defined as. So our error term is our observed data point minus our predicted data points. And we're going to do this for each data point. So you can see for as many data points we have, we're going to have a certain error value for each prediction, okay? And doing a little bit of algebra here, our predicted error term is going to be defined by the actual observed data point, our y1 through y5, and our predicted y. And remember, our predicted y is the function of our beta 0 plus beta 1x. So we can substitute the equation for y hat I with beta 0, beta 1, and we're going to have our predicted value for the error term is going to be our yi minus our beta 0 hat, beta 1 hat xi, okay? And the idea is we want to take that initial equation, we want to sum the square of that error term, and we want to make it as small as possible. Okay, so imagine we have 100 different lines going through this data point. We would calculate the error terms, we would square them, we would sum them, and we would have 100 different values for this sum of the squared error. We want to pick the value that has the smallest, we want to pick the value that has the line has the smallest error term. So using an equation, we show this by having the minimize function of our sum value of the squared error term, which our error is, again, error term is defined as our yi minus beta 0 hat minus beta 1 hat xi. Okay, so this is essentially what we're doing when we draw this line through the data. We are drawing the line that has the best fit, that is, has the smallest squared minimizes the squared error term between our predictions and our actual observations. So when we talk about doing OLS, R is essentially doing this for us in the background, computing a line with a y-intercept and a certain slope that allows us to calculate the minimize of the squared error term, and we can draw this line. Okay, so this is a very simple graphical explanation, an example of a simple linear regression with one observed variable x. So we'll go into the next video, just review some of the major OLS assumptions, some of which you'll need to look at for your lab for this upcoming week. So make sure to look at some of these assumptions before doing the lab.